Minors and cofactors of a matrix. Let's take a matrix A whose elements are A11, A12, A13, A21, A22, A23 and so on. Here the first number of the subscript corresponding to each element represents the row number and the second number represents the column number of the element. So for A11, its row number is 1 and its column number is 1. For each element of the matrix, there exists a unique minor and cofactor. Since this matrix has 9 elements, so it has total 9 numbers of minors and 9 numbers of cofactor. To find the minor of an element, we have to first neglect all the elements present in the same row and same column. The determinant of the remaining elements is called the minor of that element. For example, to find the minor of A11, we have to neglect these elements. Then we have to find determinant of A22, A23, A32 and A33, which is nothing but the difference of their cross multiplication. So it is equal to. Now the cofactor of an element is represented by the -1 to the power row number plus column number of that element into minor of that element. So cofactor of A11 is equal to -1 to the power 1 plus 1 into determinant of A22, A23, A32, A33. To clear the idea on cofactors and minors, let's take an example. Since this matrix has 9 elements, we will get 9 set of minors and cofactors. Let's find them one by one. First we will find minor of 2. So we will neglect these elements. By finding the determinant of the rest elements, we will get the minor of 2 as -12. The row number of 2 is 1 and column number of 2 is also 1. So the cofactor of 2 is equal to -1 to the power 1 plus 1 into minor of 2, which is equal to -12. Now we will find the minor of 1. So we have to neglect these elements. By taking the remaining elements, we will get the minor of 1 as 18. The row number of 1 is 2 and column number of 1 is 1. So the cofactor of 1 will be -1 to the power 2 plus 1 or -1 to the power 3 into 18. -1 cube is equal to -1. So the cofactor of 1 is equal to -18. To find the minor of 7, we have to neglect these elements. By taking the rest elements, we will get the minor as 20. This number belongs to third row and the first column, so its cofactor will be 20. For 5, by neglecting these elements, we will get the minor as -19. Since this number belongs to first row and second column, so we will get odd power of -1 and hence cofactor of 5 is equal to 19. The element 0 will also have a minor and a cofactor. For this, we have to neglect these elements. By taking the determinant of the rest elements, we will get the minor as -24. By considering its row and column number, we will get an even power of -1. So the cofactor will be equal to -24. For 3, we have to neglect these elements and hence we will get the minor as 2. By considering the row and column number, we will get an odd power of -1, which results the cofactor as -2. For 6, we have to neglect these elements. Hence we will get the minor as 3. The addition of row and column number of 6 results even power of -1, which results the cofactor of 6 as 3. For 4, we have to neglect these elements. And by taking the rest elements, we get the minor as -29. Since its position is 2, 3, so the cofactor will be 29. In the similar way, we have to neglect these elements for 9, which gives the minor as -5. The cofactor of 9 will be -5. Let's try to understand the determinant of a matrix in terms of minors and cofactors. As like we discussed before, to find the determinant of a matrix, we have to first choose a row or a column. Then we have to put the signs plus, minus, plus alternatively. After that, we will write all the three elements corresponding to the column. The determinant of the matrix A can be described as A11 into minor of A11 minus A12 into minor of A12 plus A13 into minor of A13. This is also can be written as A11 into minus 1 to the power 1 plus 1 into minor of A11 plus A12 into minus 1 to the power 1 plus 2 into minor of A12 plus A13 into minus 1 to the power 1 plus 3 minor of A13. Since cofactor is equal to minus 1 to the power row number plus column number into minor of the element, so we can write determinant is equal to A11 into cofactor of A11 plus A12 into cofactor of A12 plus A13 into cofactor of A13. Thus, for this matrix A, if we choose this first row, the determinant of A can be written as 2 plus 5 plus 6. The position of 2 is 1, 1. By neglecting these elements, we can write 2 into minus 1 to the power 1 plus 1 into determinant of 0, 4, 3, 9. The position of 5 is 1, 2. By neglecting these elements, we can write minus 1 to the power 1 plus 2 into determinant of 1, 4, 7, 9. The position of 6 is 1, 3. Here we have to neglect these elements. Now we can write minus 1 to the power 1 plus 3 into determinant of 1, 0, 7, 3. Further solving, we will get the determinant of A is equal to 89. This is it for today. Thanks for watching.